Negating logical statements. In mathematics, we want to show that certain statements are either true or false. An explanation which demonstrates a sentence is true is called a proof. An explanation which shows that the negation of a statement is true is sometimes called a disproof. Being able to negate statements properly is important in many explanations. For instance, in a proof by contradiction, we assume that the opposite of a statement is true. If we have a statement A, then the negation of that statement is represented by not A. A and B is true if both A and B are true, and it is false if either A is false or B is false. Not A and B is the opposite of this statement. In other words, it is true if and only if either A is not true or B is not true. A or B is true if either one of A or B is true. It is false if both A and B are false. The statement not A or B is the opposite of this. In other words, it is true if and only if both not A and not B are true. These laws are named after a 19th century British mathematician, August de Morgan, and are known as De Morgan's laws. Statements that say something is true for all elements in a set are AND statements in disguise. Statements that say that there exists an element in a set are OR statements in disguise. The negation of either of these two statements is a version of De Morgan's law. It is not the case that something is always true is the same as there is a case where it is not true. We also have it is not the case that there is something true is the same as it is always the case that the statement is false. We have previously seen the truth table of a conditional statement, if A then B. There is exactly one case where it is false. The statement if A then B is false, if and only if A is true and B is false. That means the opposite of if A then B is A and not B.